Thank you. Today's topic is troubleshooting condensing boilers. I'm going to go over some of the common things we run into with condensing boilers, talk a little bit about that. And get to my, oh. So the agenda, we're going to go over the tools that you'll need, understanding of the sequence of operation on boilers, a little something called symptom versus cause, and I'm going to go over some common issues and failures that you can run into on condensing boilers. Then we'll talk a bit about water side issues, and then fire side or combustion issues, and lastly about noise. And then I've got a little bit of work on the website that I want to show you. US Boiler has a pretty neat troubleshooting tool available to contractors. So tools you need if you're going out to work on a condensing boiler. You're going to need your hand tools. A lot of the condensing boilers use Torx bits. There's a lot of metrics on them, so you probably want a set of maybe small and large metric Allen keys, some screwdrivers, like I said, Torx bits, and then you're going to need a manometer. So this can be a digital manometer. It can be a U-tube. You need something to be able to measure gas pressure. You need a combustion analyzer. I've heard guys say they can set up boilers. They can look at the flame by eye. You cannot do that on condensing gas boilers. You must have a combustion analyzer. So my advice to contractors is beg, borrow, or steal, but you need to have a combustion analyzer. That is your window into what's going on with that boiler. I would recommend taking cleaning tools with you if you're going out on a condensing boiler. A lot of what we run into with troubleshooting and issues ends up being service or lack of service. So tools for cleaning the boiler, a soft bristle brush, nylon brush, maybe a 1-inch plastic putty knife, taping knife, old credit card, something to get in between the tubes on a water tube boiler, a spray bottle, and I've actually used CLR, calcium lime rust remover, on some boilers on the stainless steel water tube boilers as well. I would recommend a service parts kit, depending on what boiler you are working on. It may make sense to have the parts that you might need. US Boiler does offer toolbox, tackle box kits. I can show you one that I have here. It's basically a black toolbox kit packed full of parts, all the gaskets, O-rings, there's sensors, flame rod, igniter assembly, all the small parts that you'd need if you were servicing a boiler are in there. The other thing is the install, operation, and maintenance manual. That's probably a good idea to have. There's a lot of information in that. Almost everything that you need to know to troubleshoot a boiler is found in that IO&M manual. And lastly, and most everyone has one, a smartphone. A picture's worth 1,000 words, and with the technology today, the fact that we could do FaceTime or one of these Zoom conferences, and I know service isn't always the best in the areas that boilers are located. That's still, make use of that technology. US Boiler has a great tech department. You can call your salesman at ROI. We can, if we can't help you, we can get you in touch with the right people. So think about that before you're going out to get into troubleshooting a boiler. So the important thing when we run into trouble on a boiler is understanding the sequence of operation. So we need to know what's supposed to happen and in what order. Having a basic understanding of combustion, we need fuel, spark, and air. But in a condensing boiler, most of the time, our air is provided by a fan attached to our gas valve. The control of the boiler will tell that fan what speed to run at. So, and then we're providing fuel and trying to light a flame at a certain point off of that burner. So these are basically power gas burners inside a boiler. You can think of them that way. So it's critical that we have the correct mix of fuel and air at the point where that spark is, where we're trying to light it. So understanding combustion is important. And I always recommend, guys, take a look at that I/O&M manual before you get out onto the job site, so you have at least an understanding of what's in there and where you might need to look for it. Most of the condensing boilers, in fact, all of the ones we sell through US Boiler, use a negative pressure gas valve and venturi assembly. So it's important to understand how that works. If you can swap your screens right now so that you can see me in full screen mode, I just wanted to give everyone a quick idea of how that works. And what I have is a gas valve. This lower portion is our gas valve. We have a venturi assembly, or an air inlet assembly, and this would bolt onto a blower. So we have a blower sucking air in through this opening. As it comes in, when the gas valve opens, it doesn't really let gas through. It's still holding it back. That airflow traveling across this venturi pulls the gas up in and gives us our gas mixture, which then goes up into the burner and is ignited. So that's kind of how that works. You can flip me back to so you can see the presentation now. The other thing you want to do is have a good understanding of how to get into the control on this boiler. At US Boiler, we use the same control and display on all of our condensing boilers. In fact, we use the same passcode to get into the installer menu on all of our boilers, which is 86. But there's an awful lot of information available through that display without putting the passcode in. Simply going to the status menu or the details menu from the very first screen allows you to get in and see all of the temperatures at any of our sensors. If the boiler's running, it will show me my flame signal in microamps. And if I get in to the error screens, it'll show me a history of any lockouts that I've had. So that's going to be valuable information in trying to troubleshoot a problem with a boiler. Now I want to talk about what I call symptom versus cause. And when I do trainings for technicians, I always tell the guys, you don't want to be a parts changer. The idea here is you've got to find out not only what the problem is you're seeing, but what caused that problem. So as smart as we'd like to think these boilers are, and everyone says they have self-diagnostics in the control can only report on what it sees or doesn't see. And if something's not happening in the right order or doesn't have the right value, it's going to report it. From there, it's up to the technician to diagnose what caused that after he sees the symptom. And remember that boilers are a small part of a heating system. When they're locked out, it's easy for a customer to blame the equipment, but it could be something beyond that. It could be the installation. It could be something in the system causing the problem. So we really need to look beyond the boiler or part and determine if it's what's causing the problem. So I threw an example on here, and one of the most common things we could run into on a boiler is flame failure. So what could cause flame failure? If you look in the manual, one of the things they'll tell you is, you know, to check your flame rod. For you guys, I don't know if you've seen a flame rod before. I'm going to hold it up to my, once I figure out where my camera's at here. It's nothing more than a piece of a metal rod that goes through a ceramic insulator, and that reads flame current back through. I want to say we probably sell hundreds, if not thousands of these in a year's time. I've maybe seen 2 bad ones. But what can happen to these due to bad venting, bad grounding, a boiler that's not set up right, is they may bend out of shape. They may get coated with a coating that limits their ability to transmit flame current. And a problem I've seen is guys will say, oh, I put a new flame rod in. Well, you probably bought yourself a week, maybe 2 weeks, maybe even a month. But whatever caused that first one to read a bad flame signal, it's going to happen again. And now you're going to have an upset customer that you didn't take care of the problem the first time. So it's important to dig into things a little bit and try to figure out exactly what's going on. So I just put a couple of common issues or failures that we can have on here. The first one I want to talk about is ignition failure, flame failure, loss of flame signal. So when that happens, so a boiler fails to ignite or flames out during ignition, during flame proving, or after the point of proved flame and it was running for whatever reason, the flame dropped out. We know that we need fuel, spark, and air, and we need them in the right mixture and at the right place and the right time in order to have ignition. So I guess number one is, do we have fuel? Is there fuel there? That being said, is our fan running? Do we have air? If the fan's running, we don't have an adjustment on our fan. It's always fixed at whatever speed the control tells it to run at. We do have a fuel adjustment. Some of the causes for this could be a dirty heat exchanger. So again, having a boiler that hasn't been serviced properly. It could be venting. It could be that we're pulling in exhaust into our combustion air. We could have low gas pressure or a bad regulator. I've run into bad regulators on propane installations. It could be a frozen regulator if we're having very, very cold conditions. It could be a stuck Venturi flap, and I'll show you what I mean by that. I actually have one here, and you can flip your view now if you'd like. But the venturi that we use to pull the air in, see if you can see this. If you notice, there's two ports there. And I'm showing them both open now. The orientation this sits in the boiler is like this. So the bottom flap, the bottom half is closed. And we've run into a couple boilers now that were installed without intake air. So it was a venting issue. Enough grease and grime got in where it held this flapper down or held it up. And that was the cause that we couldn't get the boiler to light, couldn't get it to run properly. Our gas air mix can be out of range. It could be the boiler wasn't set up properly from the beginning. If it's a K2 or an Aspen boiler, it could be the orange wire. And you see I put that in caps. I actually have a slide coming up here that I'll talk a little bit about the orange wire. But rarely, very rarely, is it your flame rod or your niter that's causing the issue. The fact that you have bad flame signal or fail to ignite is a symptom, and you've got to find the cause. The orange wire. We actually use a condensate safety switch so that if our condensate tank inside the boiler, our condensate bottle would get filled up or threaten to overflow, it would shut the boiler down. And there's a couple contacts on that if they happen to get moist or wet, they will get some corrosion on them. And there's an orange wire that runs from a Y connection on the flame rod wire down to that switch. We actually tell you on the K2 fire tube boiler to just cut that connection. On the K2 water tube, there's a terminal plug, like a Molex, you can pull apart there. That wire's not necessary. It's a redundant safety. So we can actually cut that wire. If you're having a low flame signal and your combustion looks good by the numbers, so if you can watch your flame signal while the boiler is running, and as you pull that wire apart, it might go from 1 microamp up to 25 or 12 to 25. If that's the issue, it'll make a huge difference when you disconnect that wire, and it's okay to leave that disconnected. We talked about venting issues. This is a job from a few years back that I found that they were having combustion issues. And you can see here, one thing I should mention, manufacturers of gas appliances, I don't care who it is, if there's a 100-page installation manual, there's probably 40 pages on venting. And there's pictures with arrows drawn through it, happy faces. They've really tried to dummy-proof venting because, number one, it's probably the most important thing you can do to make sure this boiler is going to run the way it's intended and have a long life expectancy. And it's a safety issue. So we give you clearances where you can put terminations where you can't. And if you look at this installation, what do you think? They're going to probably have some issues there with exhaust gas recirculation. It's going to blow that exhaust out. There's a reason there's piles of leaves in the corner there. The air just gets in there and swirls around. So we're going to pull our exhaust gases right back through. So I always like to take a look at venting when it comes to troubleshooting boilers and make sure that it's done by the book. I always tell guys, if we don't show it in the book, you can't do it. Another thing we run into would be a limit string fault. and that's going to give you an error code 2 or 3 on the display. You can look at the display and it will actually show you which limit is open. It has a little blinking box. The first one that's blinking is your problem. So you need to get that taken care of. We have to close all of our limits in order to get to direct ignition, where the boiler actually lights. And we can view, if we just go to the status screen, we can see what part of the ignition process the boiler is in. Pre-purge, drive light off, pre-ignition, and then it'll go to direct ignition. If we don't get to direct ignition, we've got a limit that's holding us up. And we can actually jump the limits out to determine which ones are the problem. So if I think, oh, my flow switch is the first one, I can go jump that flow switch and just see if that boiler lights. Now, if it lights, chances are, though, it's not a bad flow switch. The flow switch is probably right. I may not be flowing any water. So now I've got to start to research that problem. The other thing that I wanted to mention is that we can actually take, and if we get an error that says we have a sensor that's shorted, or we suspect a sensor, we can take a new sensor right here with the Molex plug, and without taking anything out of the boiler, just unplug it from the boiler, that's the sensor that's in the boiler, plug it here, let it hang there, and then see if the boiler lights up and we see the correct values before we go changing parts out. So just another tip there. The other thing on an error code 2 or 3 or a failure to ignite, I would check for a dirty burner. If we get our air pressure switch, say that 3 times quickly, that doesn't make, but my blower is running, there's a chance I could have a plugged up blower. Our blowers are basically, they look like a soup can with a bunch of little holes around. And if we're pulling in dirty air, those holes can get plugged up, and then our product, we can't get that gas air mixture to go out through them properly. So I would recommend checking for a dirty burner. And we can actually, if we see that, you can take compressed air and just blow that burner out with compressed air, blow whatever's in there out. The other thing is to check for loose wiring. Anytime we're dealing with limits or sensors, I always go through and make sure we don't have loose wiring. If the limit that is not closed is our flow switch, then on the water side, I probably want to check for boiler circulation, make sure that circulator is operating. And you can do that with your meter. You can put the amp meter on, make sure it's drawing the proper amps. Any questions at this point, Chris?
We had none of the question feature in the chat feature, but if we can open up if anyone has a question.
Well,
all right,
I'll continue on here. Okay. So I want to talk a little bit about some things we could run into on the water side of the boiler. If it's a water tube boiler, it must be primary, secondary. So all the manuals show this. We even sell an accessory kit for our K2 boiler called the Fast Pipe that takes all the mystery out of primary, secondary piping. But if it's a water tube boiler, it really needs to be piped primary, secondary for it to operate properly. Again, the flow switch must prove water flow, or the display is going to show error 2, limit string fault. And we need to then research that and determine why are we not getting flow through that boiler. And there may be a couple reasons for that. Air in the system or air in the heat exchanger. So you need to purge air from the heat exchanger and out of the entire heating system. We provide a air purge fitting on our heat exchanger that has a probably a 10-inch flexible black tube connected to it. Makes it real easy to get the air out of the heat exchanger. And US Boiler has some short videos available on their website, one of which is strictly about purging air from that heat exchanger. So, is the boiler circulator working properly? We might get an error number 4, 14, or 16. This could be too high of a temperature rise or too high of a temperature, period. You know what happens in these water tube boilers, they may only have a quart or 2 quarts of water in the heat exchanger, and we might be firing them at 180, 199,000 BTUs. So flow becomes very critical. If flow is not there, or if the proper flow is not there, we can actually flash the steam in that heat exchanger. We're going to see too high of a temperature rise, and that will give us an error as well. The last thing, and this goes back to that flow switch, if the flow switch won't make, is there a Y strainer in the system? And if so, is it plugged? The problem with Y strainers, we recommend them, and we recommend you use a larger mesh in there. We really want to keep the bigger debris from getting back into our heat exchanger. Y strainers are an item that requires maintenance. You need to pull the screen out and clean that periodically. The problem with Y strainers is they look like a pipe fitting. They start to look just like a piece of the piping, and it does not look like an item that needs maintenance. I've been on 3 different jobs where the boiler got blamed, you know, that it wasn't doing its thing, and it was a plugged Y strainer. I actually have a picture here. This is a Y strainer I pulled out of a job down in Dover, Delaware. How much water flow do you think you could get through that screen? This was a 285,000 BTU boiler, and we took the Y strainer out, and we couldn't get a replacement screen. Figured we got most of the junk out of the system at that point, reinstalled without that screen in there, and boy, the boiler fired right back up. So that was what was holding our flow back. So now a little bit, let's talk about fireside or combustion issues and some of the causes and effects of that. If we have a dirty heat exchanger, we could see error code 11, 28, 53, or 6. These are all related to either a failure to ignite, too high of a temperature on the flue. You know, it has to do with fireside issues. So the solution there is to clean the heat exchanger and reset combustion. Check your venting and your intake air for contamination. So natural gas and propane we like to think of as clean fuels. Unfortunately, If you've ever seen the inside of one of these boilers after it's run for a while and not been serviced, it'll make you rethink that statement. Another thing we could run into on the fire side is the spark gap correct? So we need to check our spark gap and make sure that's what it should be. And the nice thing with our boilers, we can actually read the flame signal right out of our display. I don't need to put a meter on it. And it reads in microamps. What I've found is a good signal is going to be higher than a 5 at light off. And then as that boiler gets up to high fire, it should be 20 plus. I've seen them in the 30s, low 30s at high fire. Again, plug burner holes. We can blow that out with compressed air. If you have that, that's a symptom of dirty intake air. So there's something going on externally, whether it's pollen, dust. I had one that was sawdust. Boiler was installed in a cabinet shop. Everything was good for the first year. Something changed, went out. We found the burner all plugged up. Well, it turns out they got a new dust collection system. And where do you think their dust collection exhaust went? Right out where our boiler intake air was. So that was an issue. Now, I talked about spark gap a little bit. So here's a picture of an electrode. The one on the left actually came out of a fairly new boiler. It was in about 2 months. The boiler was running on propane, and I happened to go out there, and the customer had never set it up with a combustion analyzer. So our boilers are shipped ready to go on natural gas. If you're going to put them on propane, you have to convert them. Certain boilers, like the Alpine, it just requires an adjustment to the gas valve. The K2, we actually have to change this venturi that I talked about. So it requires the venturi to be changed. But here was a boiler that was not converted from natural to propane, but it was running on propane. So that boiler was overfired. And you can see how distorted that igniter was. And when it gets distorted like that, what happens is we can't light it at the proper place anymore. We may be sparking at the area all the way back at the base of that igniter. And what happens then is we fill the combustion chamber up with fuel before we ignite. It actually sounds like a gun going off. There's a pretty loud bang when it finally does light. And I put a picture of a new igniter up. That's what it should have looked like. Pretty similar to that. So you can see how distorted that was. We talked about dirty heat exchangers. I got called out for a leaking boiler, and this is what we found. That boiler had never been serviced in probably 4 years, 5 years, and all of that debris, you can see how it kind of burns off of the upper portion of the tubes and starts to fill in that bottom third of that heat exchanger. And now our products of combustion can't get out through our tubes, and we get hot spots in the coils. This is where we'll start to get failures on water tube boilers because of stressing out those tubes. So I wanted to talk a little bit about setting up combustion. Whenever we work on combustion, we want to set high fire first. So we want to turn on all the heating zones, the indirect, whatever, ramp it up to high fire. We give you a range and a target. So the target's pretty much in the middle of the range. I always try to set my O2 right in the middle of that range. So I'm going to do high fire first. And I should look at my flame signal before and after I make an adjustment, see, did that flame signal change at all? And then I want to go down to low fire and verify my low fire setting as well. Talk a little bit about noise issue. We've run into a few of these. Harmonics might sound like a foghorn. Usually when the boiler first lights, it might make that, and then as it ramps up, that kind of goes away. It's more prevalent with short vent lengths. Some of the things you need to look for: gas pressure. Do we have sufficient gas pressure? Is our venting installed as per the book? Is it within specs? Is our combustion within range at low and high fire? So we want to check that. Is the noise attenuator installed? And I'll show you a slide on that coming up here. US Boiler has actually put out a technical bulletin on eliminating noise. They actually have one done up for the water tube boilers that shows you how to make the adjustments. We can actually adjust our light off rate in increments, and verify that our venting's correct and that we do or do not have a noise attenuator involved. If you run into noise issues, I suggest getting a hold of somebody at ROI or call the tech line at the factory. Not something that we want you to spend a lot of time messing around with. We've run into some of these, and we're pretty confident we can walk you through this.